This meeting is being recorded.
Good morning, everyone. Today is the November 8th, 2022, and it's our regular weekly SIG Node meeting. And welcome back, everyone. And also today is the 1.26 code freeze day, right? So I know everyone is so busy, and after the KubeCon and also the code freeze, all those kind of things. So we also have a lot of proposal, but I believe offline, some of us already processed, so some is being already crossed, and but still put there as the information to updates to community here, right? So us. So David and Eric, do you want to start?
Sure, I can start. This item actually is not super critical for code freeze, so I was thinking maybe I can actually move it if somebody has something more urgent for code freeze. So we can move it later. Actually, I don't want to give time if people have code freeze related things.
I think like Derek and I made a pass yesterday and today. Only thing that we are aware of is Vinay's PR, and we have one more week. So let's see what we can do. But in general, a call out, if folks have anything for 126, now is a good time to bring it up. I don't see anything more in the agenda.
Yeah, and also some is blocked by the release. Actually, I believe people already process. Like also the morning, I also start to process all those kind of things. So I think this is maybe it's okay for us to.
Okay. In that case, okay, cool. Just wanted to make sure people have time and want to bring anything up. So this is something that I've been working with Eric on. So the kind of backstory here, I just wanted to kind of get folks' thoughts about this and see if this is some problem that other few people face, or if it's something kind of maybe we need kept for, maybe this is kind of a smaller thing. The kind of story is that we have like a script that basically checks the health check of the CRI periodically on our nodes. So sometimes we have the case where the container runtime goes down, and sometimes kubeflow can still be up, or it can be kind of borked one way or another. So we have a script that basically periodically directly contacts the container runtime, the CRI, via crycuddle, and just does like a crycuddle pods list. And that's kind of a health check that we have. We run, I think, every minute or something like that. And then if we detect that there's an error there, we basically restart the container runtime. So it's kind of like a health check that we have. And this requires us kind of to run crycuddle every minute, right? And so the problem with this, we kind of realized is crycuddle is actually a pretty heavy binary. And we were kind of investigating some cases in production where we have kind of disk throttling and low disk IOPS. And surprisingly enough, the loading of the crycuddle binary, just because it's like a kind of big chunky 50 meg Go binary, actually resulted in some like additional disk IOP usage, which is kind of funny that the health check itself is causing kind of more issues. So we were discussing some ways to resolve this, and we were thinking, since the kubelet is already talking to the container runtime, maybe it makes sense for the kubelet to kind of have a health Z endpoint that directly checks if the container runtime's up. So this way, since the kubelet's already running, we don't need to load another binary to talk to the container runtime. That's kind of the proposal here. So the proposal is to add a new health check to kubelet that directly just checks if the container runtime's up. So that way we don't need to load in another binary to do that. So I was wondering if other folks think this is useful, or this is another problem you face, or how you health check the CRI in general. Yeah, I want to get some thoughts.
Yeah, I think we go by like node not ready, but I don't see a. I mean, this sounds good. It doesn't seem like seems like a useful addition.
Yeah, I also don't have any concern. But I have to admit that until I read the code, I have to say that the implementation, the description actually is confusing there. So the feature, what they really talking about, actually, it is totally, I don't have any concern. And also, I'm not sure. Yeah, I agree with this. Also, why we need another of the flag there, and but I can say that maybe because they want using the flag to control, because on doing something like the version level controlling here, because the older version don't have that healthy, right, endpoint.
Yeah, exactly. And the theory that why we were discussing flag for that is because some folks, like the existing health check, didn't check that the container runtime was up, just the kubelet. So maybe some folks, for the health checks, they don't care about checking the container runtime. And so that was kind of, someone raised that as a concern. So like that's kind of the issues. We need some way to differentiate if folks care about that. Or maybe the other question should just be built into the kubelet health check. The kubelet health check should fail if the container runtime is down for an extended period of time. It might be also a valid proposal.
David, one question. How is this different from the generic flag? Because generic flag already cause CRI to list all pods, right, frequently.
Yeah, so the difference is basically that this is just checking if, I need to check exactly what call it's making, but it's just checking if the container runtime is up, and then it's marking the health Z endpoint directly. So the difference is that, the kubelet actually exposes a health Z endpoint, right, that you can kind of curl, and you can get that as a response. So that can be used by like a script or something else that's checking the health periodically, right, as opposed to something internally in a kubelet, which is doing that.
Yep, gotcha, makes sense.
So the main idea for us is like, instead of having our script that does the health Z check right now and has also to do the container runtime check via cryctl, we could just check with kubelet directly and avoid loading in additional binaries and, creating more IO that's unnecessary. And hopefully that'll be useful for other folks as well who are doing health checks.
Yeah, David, it seems like it's just calling, cry status.
Exactly, yeah.
So when we extend and enhance that, we'll need to modify this health Z check, right? Or, getting a list of resources that are available, right?
Well, I mean, the main goal here is just to check that the container runtime's up. So like the idea is like, if the cryctl status is responding, it's up.
Regardless of networking is ready, that sort of thing.
Yeah, exactly. So the idea is to check, is the container runtime reachable, basically? Yeah.
Okay, just reachable. Okay, all right.
Yeah.
Or whatever, it's success on the status. All right.
Exactly. I think that's something we should make more clear in the PR though. So that's a good feedback to document clearly what is the actual health check checking.
One question about this is that I remember it's the NPD performed the health check, right, and restart container D. And on the NPD side, there is also code written to perform health check, and it's just that code today invokes cryctl. But actually, if we just change that part to a client code, then we don't need to load the binary either, right? Why that is not considered?
Yeah, that's a good point. I think we need to look into the NPD side. I believe right now we have some script that actually, we don't use NPD for this actually. But
okay,
maybe that makes sense as something that would be done in NPD.
Okay, because yeah, I think we use that in some other product. Basically, we use NPD to, there's a health check plugin there, and it load that runs as health check plugin to check the kubelet and container random healthiness and restart. It's basically the same behavior with the script we wrote before for Kubernetes before, and we use an NPD plugin there. And there today we are also invoking cryctl periodically from that health check code. But we can also change that to a CRI client instead if we think loading another binary is an overhead. Just another option. Yeah, another
Gotcha. But even with that option, just to be clear, if it was an NPD plugin that would be run periodically, that plugin would have to be loaded in and out of memory, right? Like it wouldn't be long running, or would it be long running?
Yeah. Today it's a plugin there.
Yeah.
And now this is why when I saw this one, the first when I saw this agenda, I pinged you because I said, so then we might have the plan and need NPD take over, so we don't need to have those script. Sounds like we never finished that work, first thing. And so that's why I loop you, I said, can you take a look? But on the other hand, I quickly, after I ping you and offline and ask you to take a look, I quickly remind actually, maybe we do, I think this feature still have the meaning because not everyone deploy of the node problem detector, right? you do want to like we could have a value even like maybe people don't deploy of the node problem detector, and then they only have like the container D plus Kubernetes. They still have a way to check. So that's why I also told myself, maybe I need to think about it from other way. I just share here the context, because we do have the NPD and there's the plugin already built, but it looks like we didn't shift the standard config from the previous script based off the check Kubernetes and also container D healthiness to that NPD. NPD but on the other hand, container D itself and the CRI itself have that healthy endpoint, maybe help other distro, because they don't deploy NPD. They have the trouble deploy NPD. So just
Yeah,
share.
yeah. But another question I have related to this is that why because another option that we can just let the container runtime expose its health endpoint itself, right? So that we can get rid of the dependency on kubelet in between. And
yes.
I just wonder why those are not those options are not considered instead of just the.
That's a good point. I guess.
Yeah.
I guess is that valuable to have like a client connect remotely to CryCuddle and check if the client was able to make that connection? Because that's kind of what Kublet's trying to do, versus if the container runtime itself is up. I don't know if that difference matters. Right? Like, is there a situation the container runtime can be up, but like it can't be reachable from like, client? I don't know. That's sort of the question.
No, Kublet's a client. As long as the socket's there, anybody should be able to go into the APIs. I mean, same thing can be said for some of our CNI services. I know there's a CNI check, and I noticed in here that it looks like you're going to check for runtime ready, image service ready, and network ready. So we probably want to look at this a little bit deeper, I think, David. Okay.
Yeah, maybe this makes sense on the runtime directly. That also makes sense. I don't know. The current kind of all the health checks are built around connecting to the CRI and then checking if that connection is successful. But if the socket's there and container runtime says it's ready, maybe that's good enough.
And also this one, basically, it is only solve the one problem, right? So basically, have published this endpoints. It's not really healthy. It's not really container D or CRI is really healthy. It's basically it is alive. It's running. The process start and into state can publish that endpoint. That's all. So I'm not sure, are we going to eventually, once we have this healthy Z endpoint, eventually we are going to build more logical there to make that it's really healthiness, and how we are going to build that, I don't know here.
Yeah.
I guess the time it takes to process the CRI, I mean, in a way, generic plug does that, right? Like how much time it's taken to.
Yeah.
Okay. I think let me go back. I'm working with someone else on this, and let me kind of gather some feedback. I think it's useful to maybe consider something on the container runtime, and let me bring this back and do some internal discussion, and then come back maybe later, get some thoughts there. Thanks all for discussion.
Which network? Yeah, it'll be an interesting discussion. I think.
Yeah. Let's move to next topic. Paco, are you here? Oh yeah, I saw you here. Yeah.
Yes. This topic is about the image pooling at the same time, and we have already have an option of to make registry QPS and burst to a limit, but I find there I recently get an issue. And the issue says this works not as expected, and I have a PR pull request to fix it, but after some rethinking about this feature seems not to make sense in most scenarios, and I'd like to ask for some feedbacks from SIG Node. And also, I think we should have a new flag like node level limiter or something else, because the current logic is just the QPS and burst, but this just limit the starting image pooling limit, not the node level limit of parallel pools, as Raywen says, I think. I'm not sure if it's clear.
Yeah, so Paco, if I remember correctly, in the issue you mentioned that somehow the users were under the impression that the limit is actually on the number of in-flight parallel image pools, but that is not the case, right? The burst actually only limits the number of pools that Kubernetes sends to runtime. It doesn't care how many pools are in flight already. So that's why we want to change it. Instead of doing the QPS burst, we want to do a node level limit on number of in-flight pools.
Yes.
Yeah, I just want to plus one. Oh, I heard echo. Oh, I just want to plus one here because I can paste some internal calculation we did trying to use this QPS to actually limit the concurrency. So it's basically impossible because the image pool request is it's a long running request. It's not just some one-time thing. Just limiting the QPS won't work because if the image take much image pool take 2 minutes, 5 minutes, just limiting how many pool you can start every second doesn't help. So like we even did this kind of very complex calculation to try to see whether we can use this to achieve some kind of concurrency limit, and just impossible. So at the end, we didn't use this at all. So yeah.
Yes, this may help in some cases, but if the image size we don't know, and the registry is hang or some other problems, I think this may help in most cases, but there would be some corner cases, I think.
Another challenge here will be, right, like even limiting to images may not be sufficient, because what we are actually pulling at the runtime layer is the layers of the images. So when we write it up, it'll be good to capture that. One more thing that we've done in Cryo is we've added an option to do an image pull within a pod C group. So the image pull gets charged to the pod instead of to the system. So if you have more resources at the pod C group, your image pull will be faster. But of course, it doesn't account networking. It's only memory and CPU.
Yeah, that's also, but that's complicated. We always try to charge to the right worker, right? So initiator, but I also understand that's kind of make the user developer to vertical in place update can help this one, but we so desperately want that things, and we can get some user exposure. I just always worry about it. This is my old experience before we have that vertical dynamic update in Borg. Basically, user is just cause more trouble, like the for customer, which is my dev developer, right? So that the developers, so like admin as also my user, but they are maybe happy because it's basically, but I shipped that problem to the every application owner. So when they deploy their services, they don't know how to configure their workload. It's make that even more challenging. So more people stopped using guarantee instead using burstable, then which as the return back to make the admin work is much harder. You can see that the cascading problem as circling. Like I say, so we shift the problem because from the admin, make admin initially sequence easier. So then charge to the each application owner. because you charge it to that C group. So then make their job maybe be kill, all those kind of things, or shrink, all those kind of things. And so they have to configure their workload better. So then before we have this dynamic in-place upgrade, update their resource in the past, so they end up they all change using something like a burstable. And once everybody using burstable, then you have to preemption all those kind of things logic. And then admin actually also have the problem because you also have the error budget, right? So for the services, what you host, so you didn't predict about that resource capacity planning better. So I just want to share people here, since we are also many of the people development nodes, or maybe it's admin here. So that's potential problem. Yeah.
Yeah, this sounds like another use case for using eBPF to detect that, okay, image pull is starting, and immediately give whatever capacity you can to the pod, as long as they're allocating the budgeting for it. And that will make things better. It's much more responsive. These are the deterministic events for which we can really use the technology.
But here's one problem for us, like Kubernetes, right? So Kubernetes, we did a terrible job on the network IO bandwidth management, and because it's kind of the way, because it's just hard for us to do, because there's the network backbone, right? So their scheduling is totally different from the CPU and the memory and the disk, all those kind of things. So we did a terrible job on those network IO. I mean, I actually say we did nothing basically, and disk IO we also did really poor. But hopefully SQL V2 we can help to do something at the disk IO. But the network IO so far, I don't think there's the good solution for Kubernetes. So they basically rely on the Kubernetes vendor to think about how they are going to integrate with their backbone network offer and to do this allocation. So and just.
I actually did one talk in the open source summit in Texas, in Austin, Texas, about bringing in QoS for Kubernetes pods. I don't know if that's something Tim also mentioned he was interested in it, but we don't have a clear set of requirements to essentially. This was more from the line of from the point of different pods have different network needs. If you have a pod that's doing image processing, like file backup, versus a pod that's processing, payment traffic, they both compete for the same network bandwidth. One of them clearly has more important things to do. So after all this dust settles on the in-place resize, maybe we'll revisit that at some point and see if that makes sense for Kubernetes.
Thanks for your feedbacks, and I have done something related, and I have opened a pull request in containerd to add metrics for image pull related thing. For example, how many images are pulling in process, and some the duration of the image pulling in a matrix, in another matrix. And if we have those metrics, I think users can eliminate, can know how to set the QPS or burst line using the using such a calculation to know.
Yeah, thanks, Bug. I think it's also important to note here that we had a lot of discussions at the summit, CRY-V2A, summit discussions around the concept of adding into the pod specifications some image service, kind of declarative information that would help explain to the container runtime the types of caching that needs to happen, how fast this particular container image needs to be pulled, whether it should be kept on, on store in the node, as well as whether or not you should use lazy, image pulling services for that, for this particular container. Different runtime handlers are going to want to pull the images into their own VM, for example, in confidential containers. So I think it sort of points out that we need some more declarative information in the pod specifications to hand down to who's handling these image pulls in this additional networks and pretty soon multi-networks on each of the networking devices that we have available to us. So we need to somehow manage this stuff through, and like Vinay was saying, we need some quality of service information in these pod specs. So we can go from an imperative CRI API to more declarative around this space. And then we can extend plugins that some of the Intel guys have been working on, to make some decisions on how to manage those images, in a common way across the entire node.
Right. I think multi-networking brings in a very interesting, that effort has started out. I was in one of those contributor summit talks. They're talking, I think, the use case of using SR-IOV NICs, the high-speed NICs, for getting bulk data that separates your pod traffic. It could overall, there are a few different design patterns that we could look at here, QoS included. Hopefully, this will evolve into better network management for Kubernetes.
I have to check the time. I know people have. So Paco, so thanks for the update. This one. So I think can we just looks like everyone agree about limited the number of the parallel pool, at least at this moment before we solve. And I think everyone agree about the node level of the limit, right? Concurrent pool at this moment. So can you summarize what we discussed here and close your current PR together with the review, and then we can working on the new what you proposed here, and continue with that new. Okay.
Okay.
Thanks, and thanks, Riven, also volunteer to help. And so let's go to next one. Vinay, I know we have you earlier. We have the chat, but I think not everyone knows what's going on. Can you update?
Yeah, I think that pretty much covers it. There was the issue that came up was with after rebasing, there a bunch of changes came in the past day or so, and there were some code changes that needed to update with the rebase. The big change is essentially adding the new CI job. I still haven't had the chance to look into why that's failing. David Porter had helped me with it, and we found that some of the config parameters weren't right, and then that it went past that. Now the API server is not coming up, so I need to look into it. Hopefully, I'll find time tonight or tomorrow to look into that.
Yeah, happy to help you debug that thing. Let's
yeah, thanks. Very much appreciated. Yeah.
No worries.
That's it from me.
Thanks, Willie. Yeah. Next one, I think sorry about the Ian. Sorry, I may pronounce your name is wrong, but can you talk about the CPU site?
Sure. Yeah, name is pronounced Ian. Yeah, I was talking with Tim and some other people about moving some a CPU set library that's used within the CPU manager primarily into Kubernetes utilities, and it's evolved into quite a little project. But I just wanted to post the PR in case anybody had some interest in opining on the deletion of Int64 variants, or kind of the deleting the no sort variant. I was originally planning to delete the no sort variants of the API, but then Tim suggested I take a look at the set API, which has a list and an unsorted list methods, and to mimic that for this library. So that's kind of the direction I went with. But I just wanted to kind of run this by people and see if anybody had any ideas or anything.
Manu, do you want to?
Yeah, I think that the move itself made sense to me. I can review the PR and see if I have any thoughts on it. Yeah.
Cool. Thanks.
Okay, thanks. That's all because I think the rest of the stuff we already covered. And any other topic people want to discuss? Okay, thanks. You got more than 20 minutes back.
Thank you.
Bye.
See you
See
next
you.
week.